We're going to be looking at the second type of function. So this is functions 102. So the first thing we're going to talk about is where to identify where graphs are increasing, decreasing, where they're constant, etc. We're going to look specifically at a graph right away. Notice I just have another execute function, just giving it to you here. With this, we can see that our graph, we always go from left to right. The graph is starting in the negative infinity and it's going up. So to about this point, notice Desmos is very nice and gives us that information. We can see here that we have a relative max because it's in the neighborhood, that's the top of the hill. That is where we are increasing to. We also have a point here at the bottom of the hill, and that's going to be our relative min. And the reason why they're called relative is because it's within the neighborhood. If it's an absolute, that means that it is for sure going to be the lowest point on your graph, and we'll talk about that a little bit further in a little bit. So looking at this, I have my values. We're going to say it's increasing. We're only dealing with the x values when we're dealing with increasing and decreasing. So it's increasing from negative infinity to negative 0.11155. We're not going to include this point. The reason why is because you are neither increasing or decreasing at that point. You're at the top of the hill. You can't include it. Then, so that's here where we're increasing. We are also increasing when we're going back up to the top there. So that is going to be from 2.155 to positive infinity. Now, decreasing. So we're going down the hill. Pretty self-explanatory there. Again, using only the x values, we're going from negative 0.155 to positive 2.155. Only one interval there. We don't need a union. So looking at that, we have a relative min and max. We do not have an absolute. This is what we call bounded. Bounded gives you the absolute min slash max. Okay, so it's going to be something around the lines of I'm bounded above or bounded below. You are also going to have bounded by the domain. When you're talking about bounded by the domain, let's say for instance, this is easier with a picture. Let's say for instance, I have y equals 5. I'm neither increasing or decreasing. I don't have a min or a max. It's just one line. So I'm bounded by that domain to have that value. Again, mins and maxes is pretty easy to find. Just graph it on Desmos, and then Desmos will calculate those points for you. The other thing to talk about is whether a function is even, odd, or neither. Now, with this is all dependent upon substituting negative x in. If your function is even, you're going to have a regular f of x. When you substitute in negative x, if it results in f of x the exact same, then it's even. It's odd if you substitute negative x in and all of this becomes negative f of x. So basically all the signs switch. Okay. If it's neither, you have some signs change, some not. So let's say for instance, I have f of x equals x cubed minus x. So when I look at this, I personally always look at, okay, well, it's probably going to be an odd because my highest degree is a 3, but let's see what happens, right? So if I plug negative x into here, whenever I cube a negative number, it results in a negative. So I'm going to have negative x cubed here. I have a negative there, double negative, so it's going to be a positive. All of my signs switched from the original, so this is odd. To give you another example of this, let's say that I have f of x equals 2x squared plus x. Okay, I'm going to substitute in that negative x. So I have 2 times negative x squared plus negative x here. Okay, square gives it a positive, so I have positive 2x squared minus x. Well, looking at this, the x squared sign stayed the same, and the x sign went negative. So this actually is a neither case, because all of the signs did not go in the same direction. I know in the first video we talked about asymptote lines. I just want to touch base again with the vertical asymptotes, because like I said, those are easier to figure out and pinpoint. However, you could have some issues with it when looking at simple cases. So let's say that my function is x plus 2 divided by x squared minus 4. Now, a lot of people will look at this and be like, okay, first thing you want to do is set the denominator equal to 0, solve for x. Okay, that's generally what you want to do. However, because you have an x squared, this is technically your second step. Your first step is to factor, because sometimes things will cancel out and you might have a whole or a removable part of the discontinuous function. Now, I am quick factoring my bottom part. If you need help with the AC factoring, research or go look up on YouTube my AC factoring. Notice the x plus 2, these are the same. Because of this, when x equals negative 2, this is a removable discontinuity, and it's not actually a vertical asymptote. However, the bottom part here, I can set that actually equal to 0 and find that vertical asymptote line. And I found it there. The horizontal asymptote lines, you'll need to graph those on Desmos in order to find those. Caution when you graph this on Desmos, you might not see that x equals negative 2. It'll look like on Desmos that it goes through that point, but if you hover over that point, it'll actually show you that it is in fact a whole. So just be cautious with that. Make sure you're actually doing it algebraically in order to look for those vertical asymptote lines.